We are Group 2, Leap Vision. My name is Rich Chen.
Ashay Minocha.
And Andy Stancio.
All right, hey everyone, we are Leap Vision. And so our project was to build an app to help the user with practicing for LeetCode style interviews, particularly the cases where you have handwritten or whiteboarded code, such as in many in-person interviews. And so to that end, we built this app, Leap Vision, which is a mobile app that will convert an image of handwritten code to text in real time, and then execute the problem via LeetCode, responding with the result. And so the architecture basically follows this 6-stage pipeline. So the first step is this front end, which is the app that the user actually sees. This is on their mobile phone, and it contains access to the user's camera so that they can take a picture of the handwritten code that they have. That photo is then passed into a text recognition model pipeline where the image has its text extracted as code. Any errors in this process will prompt the user to make any edits as they see fit in order to ensure that the next few steps work. And so over here on the right side, we can see an example of basically handwritten code on paper, and then the corresponding extracted text from that code. The recognized text is then passed into language-specific parsers to be transformed into an abstract syntax tree, which is just an internal data structure we use here. That tree goes into a vectorizer, which transforms it into an adjacency matrix, which will just be an intermediate representation for our next step. And so here we can see the corresponding vectorized representation. So we just showed a part of the matrix since it's a very large array of data here. That goes into the next step, which is the classifier. So here we use a nearest neighbors approach to basically cheaply and quickly classify that vectorized representation from the previous step in order to extract exactly which LeetCode problem the user's handwritten code corresponds to. And so here we can see the returned categories based on that vectorized representation from the previous step. And we can see the highest likelihood category, this top one, is the correct classification. That category then allows us to go to our endpoint where we can then call LeetCode, returning results to the client app. So we make these two calls with some user session cookies that are as follows here. And then we can see what happens in the case of a correct solution and an incorrect solution, depending on what LeetCode returns. Cool. So now with regards to our evaluation, there are two main components to this for the evaluation. So the first part of the evaluation would be the text recognition and the OCR model. And the second part of the evaluation would be for parts 3, 4, and 5. So the parser, vectorizer, and classifier treated as one combined unit here. So I'll start with the code text recognition evaluation here. So to evaluate this, we constructed 3 different data sets for this. So the first data set is just handwritten code and corresponding ground truth text of the code. And this is basically just gathered through manual labor. So some of us wrote examples that you see here. And then we also outsourced some labor to friends. For the second data set, this is done programmatically. And so this is basically we take a snippet of code that we already have in a computerized representation and then generate the corresponding or generate a corresponding image just with a default computer font. And so it is a very blocky representation, so to speak. And then finally, we apply fonts to some of the generated examples from the second data set and produce this sort of generated handwritten font data set. And so the idea here is that some of these fonts are meant to simulate what handwriting would look like because the costs of getting a lot of handwriting data were a little high for the project. And so we take a look at our OCR results here with 3 main metrics. So character level accuracy. So basically what percentage of the characters in the data set were accurate. Word level accuracy, so what percent of the words were accurate. And then line level accuracy. And we find that the OCR model is actually incredibly effective at these 2 metrics of character level and word level accuracy. So that orange line represents the mean of the results. And the mean for actual handwritten examples is around 97% at character level accuracy and 95% for word level accuracy. We do see long tails for the actual handwritten data set, This suggests that in cases of messy handwriting, it is very likely that the model will have trouble recognizing that, which basically aligns with our hypothesis. We notice that performance on line level accuracy is considerably worse. This is, however, not necessarily a problem, since this is generally because the model tends to have trouble identifying exactly how many empty lines there are between particular lines of code. In terms of the semantics of the code, this is an irrelevant detail. And so for any of the later steps in the pipeline, this doesn't actually matter. And then here's a corresponding violin plot for this, where we can see again, the distribution is heavily skewed towards high accuracy here, with just a few outliers lying out past this bottom line on the box plots is the bottom 25th percent quartile minus 1.5 times the interquartile range. And so basically everything past that is an outlier. And then finally, for our evaluation for the parser vectorizer classifier pipeline, we found that this had excellent results here. So we found that using just the first nearest neighbor, we were able to get over 50% accuracy on classifying the problem, with top 3 accuracy being over 70%. This may seem low, but in the grand scheme of things, this is primarily because most of the problems on LeetCode in terms of their popularity follow a roughly Zipfian distribution. And so well over 50% of the problems are extremely unlikely to show up. And so from the user's perspective, it's extremely unlikely that they'll actually run into any of those. On to the live demo.
Yeah, actually, one more thing about these tests that we ran. We found that top 10 accuracy was around over 90%. And we'll see in the demo that we actually will display one problem, and then if there's a see more button, you can keep looking at problems until you find the one you're interested in. Cool. I'll hand it over actually to Ashay to talk about a little bit about what went into the front end while I set this up.
Yeah. So in terms of making our mobile application, I chose Swift to build this framework because I mean I was kind of starting the front end, and I have an iPhone, so it's easy for me to like build on my phone and develop in that sense. And Swift is nice in that you can really make use of like a lot of what iOS has in their Swift like features and make it look nice. And a big part of getting this like functionality down was getting the camera integrated, because like we want the ability to not only can you with our app now you can just like access your camera roll, and this was from just looking at some like Swift documentation and like accessing like the photo libraries, photo stream. But through our app, you can also like take photos live, and then you can just interact with the photo of the code from there. And yeah, in the application, basically, I implemented like making the API call to our execute logic, which is running on a server on our computer, and that kind of like just outlines how the front end can connect with the app.
Cool, yeah. I'll jump right into it. This is our home screen right here. There's an option to take a picture. I already have these pictures pre-saved, so I won't demo that now, but I'll select an image from my camera roll. And let's go back to that two-sum problem that we had originally. I'll select it and click execute code. You'll see it starts processing for a little bit. And so at this point, it's doing the classification. Cool. It has a little screen where it says, here's what we got, and then the solution there. Syntax highlighting looks good to me. Then it asks, okay, what are you solving? So in this case, it thinks two-sum is the problem we're solving. In case that wasn't it, there's just, you can see more and more problems, but in this case, it's two-sum. So I'll go ahead and click on that one. It starts loading. It's going to submit it to LeetCode. And our solution is accepted in this case, with all the LeetCode stats, and again, the code displayed. Say I were to click on, I don't know, even though it's two-sum, say I were to click on largest positive integer that exists with its negative. What will happen? Well, in this case, it's an incorrect solution, obviously, and it'll display the compile error in this case because it couldn't find the find max k method. Yeah, obviously. One other thing I want to demo, let's see, I have another file or image for first missing positive, except it's a little bit incorrect. I'll use this as an example to show it's predicting or to show the output for an incorrect solution. Okay, looks good. Oh, first missing positive. Oh, this might be the fixed version. Let me see. There's a fixed version. Okay, this is the fixed version. Anyways, cool. Obviously, it supports more than just Java. That was one of the cool things we did. So I think Rich didn't mention this, but actually as part of the vectorization, we sort of map everything to a language agnostic syntax tree. And so what that allows us to do is it allows us to support, in this case, we're supporting 8 languages. So for example, let's see, I have JavaScript here. And actually, Akshay, if you want to talk over this, Akshay worked on the JavaScript mapping specifically.
So this is just a, like Andy said, we had mappings for each language to be able to just like train one canon and use that meta language that he defined. And so this problem is in JavaScript, and this is what the parser returned. And we say it looks good, and then I don't think I'm solving base 7, but I can just like see more. And what see, I was solving single number like which if there's a single number and a array that like contains duplicates of like all the numbers, and then that's the problem. So I just click on that, and then this wasn't accepted, and then yeah, this was a JavaScript solution, and it got that too.
Is the classification worse off with JavaScript, or
Sorry?
is the classification result, because it didn't really show up in the top 5 or top 10?
Yeah, so the classification, so yeah, classification is probably better for C++ and Java because we have the most examples in those categories. JavaScript is less popular of a language. Actually, if you want to pick, this is a Golang example here. I think what's cool is that since we're using an LLM, it'll be able to extract this even with a bunch of other text in the background. Go ahead and click execute. Okay, cool. But yeah, JavaScript is probably significantly not as performant. But let's see. I think if I remember correctly, yeah, there we go. This was solving remove element, and it got it as the top most similar problem. But yeah, I think it depends more on the problem's popularity, on the question's popularity, than the language we're solving in. I think part of that reason is because this language agnostic syntax tree is so similar between all these languages that it doesn't really matter what language we're feeding it in.
Yeah, I like remove element, for example. Like even though this solution was in Golang, I think it was the first one because remove element's a pretty popular LeetCode problem versus the one I showed before, single number. And the solution I had for it too uses some like interesting bitwise manipulation, and I don't think it's definitely not as popular as a LeetCode solution.
Cool. Before questions, I guess one final thing I wanted to show. Stop mirroring. Is that if we navigate over to LeetCode, to my account on LeetCode, I guess I just submitted remove element. And I promise I never write in Golang. So, well, exactly. I'll show you all the submission data if you don't believe me, but we have an accepted solution a minute ago here on my LeetCode account as the problem that we just submitted, which I think is cool. So it's kind of just synced with all of your code. Yeah?
Can you go here,
Yeah.
pick a random code, take a picture, and
Sure.
see how it works?
Sure, let's do it.
Something which you haven't done before.
Yeah, of course. Anyone have any suggestions? I'll just scroll through the top here.
Anyone?
I'll just scroll through the top number. What?
Trapping rainwater.
Trapping rainwater. Okay. Oh, I see it. I see it right here. So, I mean, I haven't solved this because it seems like it's a hard, but. Oh, I'm not handwriting a solution right now. I don't want to. Any preferred language?
C++.
Okay. C++. Let's see. Let's try this one. All right. C++. Just take a picture. Cool. I'm going to cast my app again. Cool. And I'll use the camera feature now. Oh.
Well, then I'm gonna take a photo.
Oh, yeah, how am I gonna take a photo? Oh no, I can stop casting it
No.
for a second. You got it? Okay.
Yeah. I prepared for this contingency.
I thought you guys were live coding the solution of that.
Oh yeah, I mean, we're not good enough at coding yet. That's why I need to use our app.
Yes.
We made this app for ourselves too.
What is it?
It's like 45 or something. Trapping rate 42. It's right there. Sure. Cool. Filter by C++ and go to like the first solution.
Where's the solutions then?
Submissions. What? How do you not have
I don't know.
solutions? Oh, solution.
Oh, there. Okay, it's weird. It's over here for some reason.
It's fine. C++.
What's the second one?
It's fine. Doesn't really matter. All right. All right. Let's hope the resolution is good enough. All right. Cool. Let's see. All right, selecting the image. Let's hope the resolution is good enough. Hope we can parse. Actually, this might be a good example of what happens when the parser fails, which right now is just a 412, and it'll say failed to parse. So we'll see. Oh, wow. Okay. Did it get it all?
This is water trap, and the body figured it out pretty
Yeah, cool. Looks good. Okay, so it doesn't find trapping rainwater, but let's see. There we go, 42. Let's run it. Let's hope the solution was correct. Oh, perfect. That's correct.
And so the solution we found was like a highly optimized one. We can see the 0 millisecond
Sure.
and the 0 millisecond runtime.
Cool.
0
All right.
milliseconds.
Anyone else have any requests or questions?
There's like a thing being
Oh.
back.
Oh, cool.
Also, I guess our original intention with this app was like for like practicing whiteboard problems. So I just want to show one example of that, which I'm just quickly writing here.
I think we're also running low on time, right?
Any questions while he does the?
Yeah. Any questions?
So I have
Sure.
so the top 10 accuracy you mentioned was
Yeah.
just a clarification. Is that accuracy on the top 10 most frequent questions or the top 10 predictions of your?
Top 10 predictions. There's 2,500 questions that we trained on, which is all of the LeetCode free questions. Top 10 accuracy is, yeah. So for a problem, we'll predict k equals however many solutions that are most similar to it. Top 10 is those top 10 solutions.
So last time when we talked about what similarity metric you're using.
Yeah.
What happened there?
Yeah, so we're doing a KNN based classifier. We're doing using cosine similarity. We found marginal gains with it over Euclidean, like 1 or 2%, but that's good enough to use it. Computational time is not really a worry for us. It's super fast. Honestly, the part that takes the longest is the OCR. That's maybe like 4 to 5 seconds. Is that ready?
Alright, let's
Yeah.
do this.
Cool.
I also
I'll take the
tinkered
picture.
with other similarity
is-
metrics, and we found that there was no significant
I guess.
improvements.
Let's see how good it is at recognizing code from this angle.
Oh, that's a.
I mean, this is really just testing Gemini's capabilities, but
So this should be maximum product of 3 numbers in Python.
okay.
That's slightly like not even like an angle.
No, this is. I'll be impressed. Maybe we can finally demo the parser error. Oh no, we got it. Okay. Python looks good. What is it? Is it that one?
Maximum product of numbers, yeah.
Okay.
Wow.
Perfect. Amazing.
Yeah,
Great.
there is like one concern, like if we use Gemini might itself correct.
Yeah.
everything. So the
That's true.
mistakes we make
I mean,
might not happen.
Does this? I mean, I can look, but does that look the exact same as what you wrote, Ashay? It looks
If you go back.
the code.
Yeah, it
Just
is.
the sort call and then max
Zero
of.
by nums one by
If
nums.
you make a small mistake. like.
Can you
Yeah.
just- Can you just change the -1 to -4, 5 or something?
Sure.
See what happens. They're really trying to break your system at this point.
Yeah. Hopefully Gemini isn't smart enough to just fix this.
I'm pretty sure I evaluated for this case.
You evaluated for it? Okay.
Because character level and word level, like
Do you want
just
to
the
check
OCR itself is.
Okay.
Let's find out.
Let's find out. Let's see what it reads. So we changed it to a -5. Oh, did it? Okay, it read that at 5 as a 2.
Oh, it fixed it.
Well,
Or-
I don't know. I don't think 2.
It
2
read
is
the
not
fine as
correct,
a
right?
2, so.
Was 2 correct?
2 was the right number.
2 is the right number. Okay. So I read it. I mean, 5s look similar to 2s, right? I mean, yeah, it's gonna still work. But if you want, if you change all the numbers, see if that messes it up.
There's also arguably a certain amount of correction that is useful in the sense that.
Just do a completely bad one because we're running out of time. Just make everything.
Yeah, just
bad.
don't forget about the sort call. Erase that.
And see what happens.
Yeah. Cool.
And that says -7, so you're definitely.
Okay. Well, yeah, that's fine. Let's see.
Can you read the 7 as a 1?
No way.
Also, wait.
little
Wait.
bit
Change this to just like maximum.
Okay.
I don't want the name in there. No. Cool. Watch it what? Okay, this is definitely not going
Wait,
to.
what happened to the numbers? Let's see the numbers.
0, 1, -1, and.
Oh, it just missed the last one completely.
Yeah, it just missed that last row. Okay. Anyways, that will not work. There's no way this works, right? It's
still
not even
it still
sorted.
recognizes
So.
the correct column. No, it's not even going to compile.
No, it's just.
Yeah.
Oh,
It's
it's
not.
not.
It's not going to compile.
Oh,
It's-
'cause I
it's-
changed the
it's
name of
expecting
the- oh.
It's expecting the function.
Yeah, so I changed the name of the function from maximum.
Or I guess in
product
this
to
case, it will
maximum.
interpret.
Yeah. Well, okay.
All right, we improved your system.
Rest of you
In a
guys.
good way.
Yeah. Cool.
All right,
It's
good
good.
job, guys. Really good job.
Cool.